हेलो स्टूडेंट्स, आज हम यूनिट 5 का ए पार्ट प्रिंसिपल स्ट्रेसेस डिस्कस करेंगे। यूनिट 5 में दो पार्ट है। पहला पार्ट है प्रिंसिपल स्ट्रेसेस और बी पार्ट है थ्योरीज ऑफ फेल्योर। दोनों के ऊपर प्रिंसिपल स्ट्रेस के ऊपर 12 मार्क्स का प्रॉब्लम आता है और थ्योरीज ऑफ फेल्योर के ऊपर 6 मार्क्स का प्रॉब्लम आता है। तो आज हम पहले समझेंगे प्रिंसिपल प्लेन्स क्या है, प्रिंसिपल स्ट्रेसेस क्या है। तो जब कंपोनेंट बायएक्सियल when component is subjected to biaxial stresses, that is sigma x and sigma y, along with the torsional shear stress, that is tau. So such stress system is called as the combined stress system. So when component is subjected to combined stress system, there are n number of oblique planes gets developed in the component, and on this oblique plane there are two types of stresses acting. One is normal stress, that is sigma m, which acts in a direction perpendicular to the oblique plane. Here oblique plane is EB and this oblique plane is inclined at an angle theta with the vertical plane. So इस oblique plane पे दो stress act होते हैं। एक है sigma n, that is normal stress, which acts in a direction perpendicular to the oblique plane, और दूसरा है tangential stress, which acts along the oblique plane. So tangential stress is sigma t और sigma n और sigma t का resultant है sigma r. So sigma r is the resultant of normal stress and tangential stress acting on an oblique plane, and angle made by this resultant stress with the normal stress direction is called as the angle of obliquity. So phi is the angle of obliquity, and first figure shows AB oblique plane which is inclined at an angle theta, और उस पे दो stress है sigma n और sigma t, और दोनों का resultant है sigma r. Sigma r is inclined at an angle phi, which is called as the angle of obliquity. Angle of सेकेंड फिगर में हम समझेंगे प्रिंसिपल प्लेन्स क्या है और उस पे प्रिंसिपल स्ट्रेस कौन से एक्ट हो रहे हैं. So same component which is subjected to biaxial stresses, that is sigma x and sigma y, along with the torsional shear stress of magnitude tau. So in such a combined stress system, out of this n number of oblique planes, there are two oblique planes which are mutually perpendicular to each other, and these two mutually perpendicular planes which carry only maximum and minimum normal stress. The tangential stress value on this two mutually perpendicular plane is 0. So these two mutually perpendicular planes are called as a principal plane. Out of these two principal planes, one plane is a major principal plane which carries major principal stress, that is sigma n1. So in the figure, QR and PS is the major principal plane, and angle of this major principal plane with the vertical plane is theta p1. And on this major principal plane, the major principal stress, that is sigma n1, acts. So major principal stress is also called as the maximum normal stress. And another principal plane is called as a minor principal plane. So minor principal planes are here denoted as RS and PQ. And on this minor principal plane, the minor principal stress, that is sigma n2, acts. Angle of minor principal plane with the vertical plane is theta p2. So major and minor principal planes are always at right angle to each other. So theta p1 is the angle made by the major principal plane with the vertical plane, and theta p2 is the angle made by the minor principal plane with the vertical plane of the component. So theta p2 is equal to theta p1 plus 90 degree. On major principal plane, major principal stress, that is sigma n1, acts, and on minor principal stress plane, minor principal stress, that is sigma n2, acts. So this is about principal planes, and the stresses acting on principal plane are called as major and minor principal stresses. Now for solving these problems on a combined loading in a component, we are using two methods. First method is analytical method. Analytical method is accurate method, and there are certain formulas. With the help of these formulas, we can calculate the desired values. So first of all, we'll consider oblique plane. On an oblique plane, there are two types of stresses acts. First is the normal stress, and another is the tangential stress. So normal stress on oblique plane is denoted as sigma n, and that is given by formula sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos of 2 theta plus tau sine 2 theta, where sigma x and sigma y are the stresses, normal stresses in x and y direction, and theta is the angle made by the oblique plane with respect to vertical plane, and tau is nothing but the shear stress developed in the component. So with the help of this formula, we can calculate the normal stress acting on a oblique plane. Now tangential stress on this oblique plane is given by sigma t, and sigma t is equal to sigma x minus sigma y by 2 into sine of 2 theta minus tau cos 2 theta. So this is the magnitude of tangential stress. Tangential stress is along the oblique plane. Normal stress is perpendicular in a direction perpendicular to the oblique plane. Now, resultant of these two stresses. First stress is sigma n, that is normal stress, and another is the tangential stress, which is along the oblique plane. Resultant of these two is called as a resultant stress, sigma r. So sigma r is calculated by this formula. Sigma r is equal to root of sigma n square plus sigma t square. So by using this formula, we can find out the resultant stress on an oblique plane. Now, this resultant stress is inclined. Resultant stress is inclined at an angle phi with the normal stress direction, and that angle phi is called as the angle of obliquity. So angle of obliquity is nothing but angle made by the resultant stress with the normal stress direction. So this angle is calculated by the formula tan of phi is equal to sigma t upon sigma n, where sigma t is a tangential stress upon sigma n is a normal stress. So if we take tan inverse of sigma t upon sigma n, we get the angle phi, that is angle of obliquity. So angle of obliquity phi is equal to tan inverse of sigma t upon sigma n. So these are the four formulas used for calculation of the stresses, normal stress, tangential stress, and resultant stress, and the angle of obliquity on an oblique plane. Now, next we have to see the major principal stress developed in such combined stress system. So sigma n1 is the major principal stress, and it is calculated by the formula sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 square plus tau square. So sigma n1 is also called as a maximum normal stress or major principal stress. Now second stress is a minor principal stress. Minor principal stress is denoted by sigma n2, and its magnitude is calculated by putting this sign as a minus. Instead of plus sign, this sign is minus for minor principal stress. So formula becomes sigma n2 is equal to sigma x plus sigma y by 2 minus root of sigma x minus sigma y by 2 square plus tau square. So in this way, we have to calculate a minor principal stress sigma n2. Now next seventh step is angles made by these two mutually perpendicular planes, oblique planes, which are called as a principal plane. So formula is tan of 2 theta p is equal to tau divided by sigma x minus sigma y by 2, where tau is the torsional shear stress developed in the component, sigma x and sigma y are the normal stresses in x and y direction. So from this formula, tan 2 theta p is equal to tan inverse of tau upon sigma x minus sigma y by 2. So from this equation, we can calculate first the angle made by the major principal plane with the vertical plane, that is theta p1. And once theta p1 is calculated, we can calculate the angle made by the minor principal plane with the vertical plane, that is theta p2 is equal to theta p1 plus 90 degree. Because we know the two mutually perpendicular principal planes, the angle between them is 90 degree, always 90 degree. Out of the two principal plane, one plane is called as a major principal plane on which major principal stress, that is sigma n1 acts, and another principal plane is a minor principal plane on which minor principal stress sigma n2 acts. So next is formula for calculation of maximum and minimum shear stress developed in the component when it is subjected to combined stresses. So tau max or tau minimum is calculated as plus or minus sigma n1 minus sigma n2 divided by 2. Here sigma n1 is a major principal stress and sigma n2 is a minor principal stress. So when this is plus, it is a maximum shear stress, and when this is a negative, then it is a minimum shear stress. So tau max and tau minimum are calculated by this formula, plus or minus sigma n1 minus sigma n2 divided by 2. So magnitude of maximum and minimum shear stress is calculated by this formula. Now angles made by the shearing plane. There are just like principal planes. Shearing planes are also two planes. One is a maximum shearing plane and another is a minimum shearing plane. So on a maximum shearing plane, the maximum shear stress tau max acts, and on minimum shearing plane, the minimum shearing stress acts. So angle made by these shearing planes, two shearing planes which are at right angles to each other, is calculated by this formula. Tan of 2 theta s is equal to minus of sigma x minus sigma y by 2 upon tau. So this is minus, tan of 2 theta is equal to minus. So we have to use formula tan of 180 minus 2 theta is equal to minus tan 2 theta. So this negative angle we want to remove. For that purpose, we have to use this formula tan of 180 minus 2 theta is equal to minus tan 2 theta. So from this equation, we can calculate 2 theta, tan of 180 minus 2 theta is equal to sigma x minus sigma y by 2 upon tau. From that 2 theta s, we can calculate theta s1. Theta s1 is the angle made by maximum shear plane with respect to vertical plane of the component. And and theta s2 is equal to theta s1 plus 90 degree. So we can calculate the angle made by the shearing planes by this formula. इस ये फॉर्मूले से हम ये एंगल्स थीटा s1 एंड थीटा s2 हम कैलकुलेट कर सकते हैं. या दूसरा मेथड है, हमने मेजर प्रिंसिपल प्लेन का एंगल पहले हमने कैलकुलेट किया था. थीटा s1 इज इक्वल टू थीटा p1 प्लस 45 डिग्री. थीटा p1 में अगर 45 डिग्री ऐड करेंगे तो थीटा s1 दैट इज एंगल मेड बाय मैक्सिमम शेयरिंग प्लेन हमें मिल जाएगा. और थीटा s2 इज इक्वल टू थीटा p2 प्लस 45 डिग्री. तो थीटा p1 में प्लस 45 डिग्री करेंगे तो थीटा s1 मिलता है. थीटा p2 में प्लस 45 डिग्री करेंगे तो थीटा s2 मिलता है. थीटा s1 एंड थीटा s2 they are at right angle to each other, so maximum and minimum shearing planes are always at right angle to each other. तो ये फॉर्मूलेज एनालिटिकल मेथड में प्रॉब्लम सॉल्व करते वक्त ये फॉर्मूलेज इंपॉर्टेंट है. ये फॉर्मूलेज ध्यान में रखना है. एनालिटिकल मेथड इज मोर एक्यूरेट देन द ग्राफिकल मेथड व्हिच इज कॉल्ड एज अ मोर सर्कल मेथड. तो अगले लेक्चर में हम एनालिटिकल मेथड सेम प्रॉब्लम हम एनालिटिकल मेथड से सॉल्व करेंगे और ग्राफिकल मेथड से, दोनों मेथड से सेम प्रॉब्लम सॉल्व करेंगे कमिंग लेक्चर्स में. सो थैंक यू, सी यू इन द नेक्स्ट.